Hey, what is up everybody? It is Mr. Boylan, and today, what in the heck are we gonna do in this video? We are going to describe a precipitation reaction in terms of a molecular, complete ionic, or net ionic equation. Seems intense? Pretty straightforward. We are first going to take a look at precipitation reaction. We're going to use a list of solubility rules to predict whether a precipitate, a solid dude, will form when solutions of soluble ionic compounds are combined. And then two, we're going to take a look at writing balanced molecular, complete ionic, or net ionic equations for a given chemical reaction. Now, these two criteria for success really go hand in hand, and some of this we're already pretty familiar with, so it shouldn't be too much of a stretch to wrap your mind around today's video. So first, something we should already be pretty familiar with, a precipitation reaction. Recall that a precipitation reaction is just a reaction in which aqueous ions, dissolved in water, in separate solutions are mixed together to form an insoluble compound that settles out of solution as a solid. So keep in mind that the insoluble compound that settles out is called a precipitate. So let's take a quick look at a precipitation reaction. I'm going to take two of these aqueous solutions. Again, two solutions in which we've dissolved a solid in water. I'm going to choose sodium chloride and silver nitrate. Notice when we mix these two solutions together that we form a solid, aka a precipitate. At the molecular level, we've got a couple of ions that are coming together to form that solid. At the macroscopic level, we see this white solid forming on the bottom of our flask. So where we're going to take precipitation reactions a little bit further is we're now going to use solubility rules to help us predict which of our products are going to form a precipitate. Now recall, you don't have to memorize these solubility rules. They're provided to you on the back of your periodic table. Recognize that if you have a compound that has any of the ions that are in that soluble ion list, it's going to dissolve in solution. But if you have anything that is in that insoluble ion list, you're going to have something that's going to form an insoluble compound. In other words, it'll form a precipitate. Okay, so now I'm going to talk to you about the steps that you need for writing precipitation reactions. The first is just to take a look at your aqueous solutions and determine which ions are present in each of your reactants. So let's come back to this precipitation reaction in which we mixed sodium chloride with silver nitrate. Recognize that each of the solutions are aqueous solutions, or the things that are in them have been dissolved in solution. And so notice at the bottom of your screen, I have rewritten the formulas for these two aqueous solutions with the ions separated as individual aqueous ions in solution. Step 2. Determine the formulas of possible products by exchanging ions. Remember that precipitation reactions are essentially double replacement reactions. In other words, the positive ion or cation from one reactant is going to hook up with the negative ion or anion from the other. So to think about mixing these two solutions together, I'm going to think about what might happen when I combine all of these ions in one giant solution. My sodium ion might be attracted to my nitrate ion, and my silver ion might be attracted to my chloride ion. And so your second step is just to think about how those ions might pair up with one another when they're mixed together in one giant solution. Your next step is then to look at each of those products and look at your solubility rules on your reference chart to see if any of those possible products are insoluble. So basically, you're just going to go to your reference chart and ask yourself, do any of the products hit any of these insoluble ions? Sometimes you'll hunt and hunt and hunt, but no precipitate is going to form. In that case, you'll just write no reaction after the arrow. Sometimes you mix things together and nothing happens. You haven't done anything wrong, we just haven't formed a precipitate. If, however, there is a possible product that is insoluble, you just write their formulas as the product of the reaction using an S in parentheses after the formula to indicate that it is in fact a solid or a precipitate. And then write any soluble products with AQ in parentheses after the formula to indicate that it's aqueous. So as I come back to my two potential products here, I've got a sodium nitrate and silver chloride. As I look at my list, I recognize first that the nitrate ion is right under my soluble ionic compound list. I also recognize that there are no exceptions to that rule. In other words, anytime I find nitrate in an ionic compound, it is always going to dissolve in solution. So as I come back to this potential product, I have to recognize that this is just going to stay dissolved in solution as a bunch of ions. I notice that my chloride ion is also under the list of ions that are typically soluble in solution. However, with chloride, there are some exceptions. One of those exceptions is when chloride is bonded to silver. In this case, it will form a precipitate. So as I come back to this reaction, I recognize that these two ions, when they come together, will actually form a solid precipitate. So yes, we are going to form a precipitate here, and we decided that it was the silver chloride that would precipitate out. So we mix the two solutions together. We do in fact see the formation of a precipitate. At the molecular level, recognize it's those silver ions and chloride ions that are coming together to precipitate out of solution. At the macroscopic level, we just see this white precipitate form. It's important to recognize that your sodium ions and your nitrate ions are going to stay dissolved in solution. They will remain as aqueous ions. And a last important reminder, when you are writing precipitation reactions, once you figure out what has formed the solid, don't forget to always go back and balance your equation. Remember, you're balancing only by changing coefficients, not changing those subscripts. Your nomenclature is always going to take precedence.